All right, here's another example for Convergence 2 basic. We're going to find the interval of convergence for that infinite series, infinite Taylor series. All right, so this has the form of a geometric series. Let's see. So we know that 1 over 1 minus x equals I'm going to write this as only when x is between -1 and 1, not including -1, not including 1. Okay, that means that this thing converges when x is between -1 and 1, and we know something even more. We know that it converges, it has meaning, and we know exactly what it means. It means that. Okay, but we only know that that thing converges when x is between -1 and 1, and we only know that, and when that is the case, when it converges, we know that it converges to that. So that's pretty cool. All right, so remember we think of x as the ratio r. So x is the ratio r. Okay, so in this problem, r equals x minus 7 over 5. And we know that this guy converges only when r is between -1 and 1. So now the question is, when is r equals x minus 7 over 5 between -1 and 1? All right, so converges only when -1 is less than r. R is that. Converges only when r, which is that thing, is between -1 and 1. So r is x minus 7 over 5. So now we'll solve for x. Okay, multiply both sides by 5. We get -5. All right, I can do all the steps here. We got 5 times -1 is less than 5 times 1. Remember that you don't have to flip. The only time you have to flip the sign is when you multiply or divide by a negative. We didn't multiply or divide by a negative. We did a positive, so we don't have to flip the signs. -5 is less than 5. Okay, now we'll add 7 to both sides, or all sides. Okay, so 7 minus 5 is 2. 12. Okay. So this thing converges only when x is between 2 and 12. So so the interval of convergence is dun 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 dun. Okay, this is the interval of convergence. This is the interval that contains all the numbers that make this converge. so this is the answer.